I want you to do this problem in your head because you're going to convince yourself that you are logically algebra savvy. I'm going to think of a number. I double the number and I add 5. My result is 13. What's my number? Well, if you think about it, the last thing you did before you got to 13 was add 5. So if you take away 5 from 13, you get down to 8. And then you knew you doubled your number to get to 8. So you must divide the 8 by 2 to get to the number you started with. So if we started with 4 and we doubled it, it became 8, and then we added 5 and we got to 13. And so you really work backwards because you started with the number, you doubled it, then you added 5 and you got to 13. But to get back to what the number was, you take away the last thing that you did was to add 5. You take away 5 and you know your result must be 8. So now you're left with 2x equals 8, and to get down to what x is, you just divide both sides by 8, and that will take you down to what x is, which is 4. So you go backwards from what you did. Hey, we're going to divide an unknown number by 2. We're going to divide an unknown number by 5, and then we're going to subtract 2. The result is 6. What was the unknown number? Well, we started with the number, we then divided it by 5, and then we then took away 2, and the resulting number was 6. So if we go back from whence we came, the last thing we did was to take away 2 from this quantity to get to 6. So if we add 2, that'll bring us up to 8. So it must be that x divided by 5 is 8. Well, if we multiply by 5, that will take us back to what the original number was, which is 40. So we're going to go in the reverse order of which we handled things in. This could hurt the brain, but it's really important. This is the problem we just did. Thinking of a number, dividing it by 5, taking away 2, and I got 6. It is important for us to know that this situation is really equivalent to this one. Here's a word problem for it. I'm going to start with negative 2. I'm going to add the result of what I get when I take my number and I divide it by 5. So do you agree that you can't add this quantity until you know what it was? So before we told what the result was, even if you said I'm starting with the negative 2, I'm going to add my number divided by 5, you would have had to do your number divided by 5 first, then add the negative 2 to that number. And then we'd say, hey, the result was 6. So even though it looks a little bit different, we're still going to get rid of the minus 2 first because it's really the last thing we had to do. So to counteract, we're going to add 2, which takes us to 8. So x divided by 5 is going to be 8. Multiply both sides by 5, we get 40. So x would still be 40. So that is equivalent to this. The point being, we don't just work from left to right or from right to left. We actually pay attention to the order of operations, the sophistication of operations, and we go in reverse order. Over here, if we, well, in fact, let me give you the game plan. Here's what we're talking about. This is what we should do. Focus on the variable side. So we say, okay, here's the variable side. If we're looking at this guy right here, then what would we have had to do first to our number? We would have had to multiply it by negative 3, because you're supposed to do multiplication before anything else, and then we would subtract the 5. So the first thing we did was to multiply. The second thing we did was to subtract the 5. So that's what had to have happened on the left side where the variable is in order for us to end up with 19. So now we go to the step where we're going to undo or go in reverse order of operations from what we initially did. So we go over here, and the way to undo stuff to get down to x is to go in reverse order of what we did before, which means we're first going to take care of the subtraction, then we're going to take care of the multiplication. And that's our game plan. So now we're going to address that, and we're going to create zeros and ones, the additive and multiplicative identities, in order to come up with the correct answer. So we first deal with the subtraction. Let's add 5 to both sides. If we add 5 to both sides, we're going to be left with negative 3x plus 0. There it is, the additive identity, equals 19 plus 5, which is 24. Since anything added to 0 is just that thing, we're left with negative 3x is equal to 24. I'll talk more later about why I want to make such a big deal about putting the 0 there. A lot of times we just say, we added the 5, that's gone, we're just left with the negative 3x. Let's keep putting the 0 in for now. Well, we need to get rid of the multiplication second, so we're going to divide by -3 to undo the multiplication, and our final answer is going to be 1x is equal to -8. But 1 is the multiplicative identity, that's why we divided, so that -3 divided by -3 is 1. 1 times x is -8, so it must be that x is -8. That's how we solve two-step equations. Assess the order of operations initially. You would have had to have done on this side, to end up with 4, you would have had to take your number, first divide it by 2, and then add the -7. So, to undo that process and solve the equation, we go backwards through that approach. We take care of first the number that's being added, which is a 7. So we add 7 to both sides. We get 11 is equal to 0 plus t over 2. Well, 0 plus t over 2 is just t over 2. And then to undo division by 2, we would multiply both sides by 2. And our final answer, 22 is equal to 1t. Therefore, t is equal to 22. Now we get to here, and this will show why it is that I like us initially to be writing down the zeros that we're creating. So let's take a look at what happens here. We assess what happened on the variable side to end up with the 4. We must have first multiplied the unknown number by 2/3 and then taken 16 minus that. So to undo what we did, we first need to get rid of the 16 and then we'll take care of this right here. Now you guys, we have to create zeros and ones. How do we get rid of the 16? By subtracting 16 so we get 0. And we do the same thing to the right hand side. Over here, 4 minus 16 is -12. On this side, this minus this is 0 minus the 2/3 y. But 0 minus 2/3 y is a -2/3 y. More on that in just a second. Well, now how do we undo this -2/3 times the y? If you've been watching the videos, we realize that we want to create a 1y, because 1 is the multiplicative identity. And the easiest, quickest way to get that to happen is to multiply it by its inverse, -3/2, because this times its inverse automatically gives you 1. Then that dictates that we're going to multiply the right-hand side by the exact same number, and if we do the math over here, we can cross-cancel. We should know how to do that, and we end up with a negative times a negative, which is a positive 18 over 1. But this then means that y is equal to 18. Now we can always know our answer is correct on a test or whatever by putting that value back into the variable to see that it works, and indeed it does. I want to point something out very important, and it's right here. There are some kids that they've oversimplified the solving of a two-step equation. They say, hey, come on, it's as easy as this, Mrs. Richardson. All you got to do is just, if you're doing subtraction, you do addition. If you're doing multiplication, you do division. If we oversimplify, then I would argue that here's what happens with a lot of our students. They see this problem, and they say, look, 16 is attached by subtraction. I'm not going to subtract 16. I'm going to add 16 because I undo what I did with subtraction. And I add 16 here. And then they get 4 plus 16 is 20. Now they're well on their way to really messing up this problem. But then it gets worse. Because they don't even pay attention to the fact that this is 32 and not 0, they say, look, I undid subtraction by adding, so I must just be left with 2/3 y, and then they lose track of the negative sign. And then they divide by 2/3, and whoa, they get the answer y equals 30, which is totally wrong. Two big mistakes, because they tried to find an easier approach to solving two-step equations. My argument, if we understand the math and we do what's right mathematically, we really, really know the math, and when the problems get more difficult, bring it on. We got it made. So a couple more. If we do inequalities, they get solved the same way, but you got to keep in mind that big exception of any time you multiply or divide both sides by a negative, you have to switch the direction of the inequality sign. So we could do this one. We set ourselves self. Assess the order of operations on the variable side. We multiply the number by something and then we subtract it. So we undo that. We go reverse order. Take care of the number that was subtracted by 3. We need to create a 0. So we'll add 3 because that will give us 0. And 0 plus the 2/7 m is just going to give us 2/7 m on the left side. That's why we do it. When we add 3 to this side to keep both sides equal, we get 10. So now, if this is greater than or equal to 10, multiply by the reciprocal on both sides, you'll have your solution. Keep the inequality sign the way it was because we didn't multiply by a negative. But this one, ugly. Try this bad boy right here. If we look at over here, on the variable side, what was done first was multiplication times the variable, and then there was subtraction involved after that. So let's take care of the number involved with the subtraction first. We need to create a 0. What do we do to -6 to create a 0? We could add 6 to both sides. We'll be left with -24 is less than 0 minus 12x. Now looky there. We don't even have to think. It's so easy. By showing the extra step of there's a 0. 0 minus 12x is -12x. So we have -24 is less than -12x. We're going to divide by -12 to make sure that we're getting x by itself. We know that this divided by this is 1x, so that just leaves us with x. And over here, this divided by this is +2. Oops, wait a minute. I just divided by a negative. I better switch the direction of that sign. I better make this go this way. So in the end, 2 is greater than x. But if we read it this way, x is less than 2. So there is where all of our solutions are. All right, there's the beginnings of two-steps equations. Knowing why we're doing stuff and creating the additive identities and the multiplicative identities, which really make the understanding of this and future mathematics much more attainable.